In the previous session, we considered the depiction of constructs. In this tutorial, we will learn how to put constructs together so they form models. Because SEM models tend to be quite complex, rather than distinguish between dependent and independent variables, in SEM we use the term exogenous and endogenous construct. Exogenous constructs are synonymous with independent variables, and they are not influenced by any other variables in the model. Endogenous constructs are synonymous with dependent variables, and they are affected by at least one other construct in the theoretical model. Take, for example, the case of motivation and satisfaction from the Bagotzi's model. Since motivation influences satisfaction, motivation represents an exogenous construct and satisfaction represents an endogenous construct. What about three-construct model? Let's add performance. Now the model includes three constructs, one exogenous and two endogenous. Let's have a quick look at the full Bagotzi's model. Which of these five constructs are endogenous and which are exogenous? Have a thought. 2 seconds. Here is the answer. The constructs on the left, my left, are all exogenous, and the constructs on my right are all endogenous. A few more words about drawing models. Whenever you see a straight line between two constructs, or straight arrow between two constructs, it means that they are related. In this instance, the exogenous construct influences the endogenous construct. A curved line like this one denotes covariance. Suffice to say that the endogenous construct covary or change together. Here is an example of a very simple model with two constructs, motivation and satisfaction, and 8 observed variables. And here is another model, this time very complicated, that's the full model from Bagotzi, with 5 constructs and 19 observed variables. To summarize, when drawing models, the constructs are always depicted as ellipses. The observed variables feature as squares. Curved lines with double-sided arrows depict covariance. Errors are always represented by small circles, and everything else is marked in straight lines. I talked a lot about models and modeling, but I haven't quite explained what I mean by modeling. Typically, when converting theory into data, we would propose that some relationships exist between concepts. For example, that satisfaction affects performance. To confirm whether this is indeed the case, we would go out and collect data, and then we would calculate whether the data fit our expectations, i.e., whether the relationship can be statistically proven. Put it in another way, we would specify the model and determine the fit between hypothesized model and the sample data to see how well the observed data reflect the proposed structure. The fit has to be quite good for us to accept our findings, and we'll talk about this goodness of fit later. Nonetheless, it is unlikely that the data will fit the model perfectly, and the difference between the two is so-called residual. We thus have data that encompasses measures related to observed variables. We have model that is the representation of the hypothesized structure of relationships between the latent and observed variables. And we have the residual, that is the discrepancy between the hypothesized model and the observed data. There are two components of SEM. The first one, CFA or confirmatory data analysis, captures the measurement element of the model and provides representation of the model constructs, the observed variables and their relationships. In simple terms, CFA shows what variables have we measured and what constructs do they relate to. For instance, in our model, performance has been measured by 4 indicators from V16 to V19. The second component of the model is the structural model. The structural model shows how constructs are related to one another. That is, the structural model reflects our research hypothesis. When the two are put together, they generate the full SEM model. To summarize, in this session I talked about key vocabulary and how this vocabulary translates into a set of depictions of models. You will be glad to know that this is the end of my theoretical chatting, and next time we will do something really exciting. That is, we will go onto AMOS and try to do some first drawing. See you next time. Bye!